All right. We actually get to take skills from the last two videos and put them together into some really impressive looking stuff. So here's the first problem that we're going to take a look at. Oh, let's say we've got something like 4x to the 5th, y to the 7th, z squared over 12. Actually, I'm going to change that. Let's change that to a 10. I like 10 better in this case. X to the 3rd, y, z to the 5th. Okay, so I can write this all out. In fact, I did in the last video. I showed you how I can write this all out. And so, but in this case, I'm going to use my rules for quotients. And first I'm going to take the numbers and go ahead and reduce them. So it equals, all right, 4 over 10, top and bottom are both divisible by 2. So 2/5. Okay, can't reduce that any further, so that must be it. All right, now we look at the x's, and we take the exponent from the top minus the exponent from the bottom, and we get x squared. X to the 2 power. 5 minus 3 is 2. And then on the y's, that'd be a 7 minus 1. So that's going to be a y to the 6th. Now, one of the things that we're going to be talking about a little bit later, but I kind of wanted to show it to you right here, is what happens with the z's. We go 2 minus 5 gives us a z to the negative 3. If we have a negative exponent, it means that we take this and we just move it down to the bottom, and that will make the exponent positive. Z to the 3rd. Okay? And then I can just take this part here and go, ooh, we don't need this anymore, and we don't need this anymore. Close enough. Okay? And this is the answer. There's nothing more to do with this. Okay, let's try another one. I'm going to give a little bit more of a simple looking one, but again, it's going to use up a couple of different things. If I just have z to the 4th over z to the negative 3, there's actually two different ways that we can do this problem. One way is just to say, hey, quotient rule says take the top exponent and subtract the bottom exponent. So that would be z to the top exponent 4 minus a negative 3. Well, minus a negative gives us a positive, so z to the 7th. The other way that we could have done this was to have said, all right, if we have z to the 4th over z to the negative 3, we can take that negative exponent, the thing raised to the negative exponent, move it to the other side of the fraction bar and make it a positive. So we end up with z to the 4th times z to the positive 3. And then we have just the multiplication rule, where we add the exponents. 4 plus 3 is equal to z to the 7th. Kind of cool how that works. Now, we could take this skill and combine it with the bigger problem that we just had, and we could end up with something like 8x to the 4th y to the negative 3z over 12x squared y, so y squared, and then z to the 4th. All right, so here we go. I'm going to go, here's my fraction bar, reduce my numbers. 8 over 12 is 2/3 because 4 goes into both of those numbers. And then x to the fourth over x squared, 4 minus 2 is 2. And then y to the negative 3 and y squared. So let's see, negative 3 minus 2 is negative 5. So I can put a y to the negative 5 up here. But it's easier to take it now and move it down here and make it positive. And then z to the 1 power minus, or divided by z to the fourth. 1 minus 4 is z to the negative 3. And we take that one, because it's a negative, and move it down. And our final answer looks like 2 over 3x squared y to the fifth z to the third. Okay, so a couple of things here. We just got to remember that we can put multiple rules together into one problem. And also, if we end up with negative exponents, we move them to the other side of the fraction bar from where they are, and they become positive. That's it. Pretty good stuff. So we will see you in class. Bye.